Hello everyone, I'm Kyung-Sun Kim. I'm excited to present our work. Today I'm going to talk about our work in mEOL, which is a training-free way to align vector graphics and images into one aligned space. Okay, let's start with a simple question. What makes SVGs special? We see them everywhere and visually. They look just like any other JPG or PNG, and unlike raster images them, SVG exists in a dual state. They're almost visual images, but simultaneously, they're a structured code containing rich geometric and layout information. Are they images? If we treat SVG merely as pixels, you're basically throwing away all the geometric structures and symbolic organization. We don't want to do that. Are they plain text? Well, have you seen raw SVG files? They are a mess. We wanted to fully use both the visual vibes and the underlying code. So here's the deal. Finding the right icon is a total struggle. Normally you type a keyword and then you gotta spend all this time thinking and searching through hundreds of options just to see which one looks proper. But SVGs are actually code, and MLLMs are already incredibly good at understanding the code. So we thought that why can't the model just do the heavy lifting for us? Basically, we want to get to a point where we just type and get the perfect asset. To make this happen, our goal was to answer remapping text, code, and images into exact same space. If we can align all these different modalities into one embedding space, finding the right icon becomes a lot more intuitive and efficient. Alright, so I'm going to break down our method into 3 main steps. First, we've got a semantic SVG module. Basically, raw SVG code is often messy and lacks semantic meanings, with nondescript IDs like layer 1 or missing ID. This is where our SVG modules comes in. We use an MLLM-based visual reasoning approach to rewrite this code, adding meaningful labels like bird or hurt based on what it actually sees in the image. It's all about making that hidden structure readable, making much easier for the embedder to process. Next up is the mEOL embedding. We instruct an MLLM to summarize diverse inputs, be it text, images, or our SVG code, into a single token embedding. We tell them, hey, look at this input and summarize it in exactly one word by using a specific instruction to summarize in one word. It forces the model to compress everything into a single token. By extracting the hidden states from the penultimate layer of the token, we get a super tight alignment. And finally, we got a retrieval process. Once everything is aligned into the shared space, we just use cosine similarity to find the best match for your query. Our results show that by incorporating SVG code through mEOL, we significantly outperform in cross-model retrieval. Look at this beekeeping and honey harvesting query. While standard models like Clip or Lave often get distracted by visual noise or just simple colors, our method, especially with the SVG code, really nails the actual concept. The coolest thing is, our model doesn't just retrieve the perfect ground truth icon for honey. It even pulls up the bear icon. Think about that for a second. There's no visual resemblance between a beehive and the bear, right? But the model understands the semantic link that bears are contextually related to honey. It's significantly more precise because it's not just looking, it's reasoning. This proves that mEOL isn't just matching the pixels or colors anymore. It's actually reasoning through the context and understanding the deep, hidden meaning behind the query. So, to wrap things up, in mEOL proves that instruction level control can be a powerful, efficient way. We get training-free alignment, structure-aware reasoning, and a way to finally unlock the full potential of SVGs. That's about it for me. Thanks for listening, and I'm happy to take any question you guys might have. Thank you.